of sustainability for industry. And in this 1.5 hour, I think those people who are listening can unmute because disturbance is coming.
It's a humble request to everybody. Please mute your mic, please. Hello, Dr. Mrityunjay. Good afternoon. Dr. Snehal here.
Good afternoon.
Sir,
I think let other people mute their one, and when they want to speak, then unmute. Otherwise, disturbance is coming.
Sir, please proceed.
So, the topic which I am going to discuss today is the concept of sustainability for industries. And actually, sustainability is very close to my heart. And at UPL, I am leading sustainability, environment, and green cell. So, what I shall do today in this talk, a part of sustainability and how to embed what it is, I shall try to explain more in terms of case study. So we are embedding sustainability at UPL, and several things we are doing. So I shall try to explain with those case study that what we are doing, what kind of result we are getting at UPL, such that you can correlate very well and also you feel practical. Because normally when we discuss sustainability, then this is the complaint of industry that the people talk theoretical, but it may not be practical and may not be implementable. So today I shall keep my talk not based upon the book, but based upon the practical implementation. And I think 70-80% I shall cover actually what we have done in last 5 years. So in 2015-16, we came out with UPL Sustainable Development Plan, and we came out with the target and goals. And now in 5 years of time, what we have achieved, what we have done in sustainability, that I shall try to cover during my presentation and this talk. But before going to that, first, since we are going to discuss on the concept of sustainability, so let's first understand what is sustainability for industry. And as a simple word, sustainability stands that sustainability. So ability to sustain is nothing but sustainability. And before going through the concept, if we can try to see that what make unsustainable in industry, then it will be very clear that how sustainability help us in the industry. So if we will talk that what makes unsustainable in industry, the first thing is profitability. If you are a non-profitable, then you cannot sustain. And first thing is that you must have a profitable in industry. Second thing is compliance. If you are a non-compliance, then you cannot sustain, and that make us non-sustainable. So compliance is must, and all the statutory compliances must meet. And third thing is social acceptability. Suppose one industry is profitable, also 100% compliant, but if socially it's not acceptable, if the people around that industry is not going to accept that industry, and if they feel that this industry is creating pollution, it's not good for the people, then also it's very difficult to stand. And I think you can have an example of Sterlite. So Vedanta Group, Sterlite, they are profitable also at Tamil Nadu Tuticorin, They are compliant also, but since there was unrest socially, so that become unsustainable. So what I feel personally, that any industry, if wants to be sustainable, then must be profitable, must be 100% compliant, and must be socially acceptable. And the solution for all these three is sustainability. So in sustainability, what we used to do, or what sustainability guide the industry, that it make profitable the industry, it's make 100% compliance, and also when we embed sustainability into industry, then it make us 100% socially acceptable. So I think the solution of sustainability of industry is itself a principle of sustainability. And so why today you will see that from last 10 year, maybe one decade, the embedding sustainability into business, embedding sustainability into industry, this is catching, and day by day it's increasing. And especially after Paris Agreement on climate change in 2015, sustainability came in the main agenda. And today, everyone have to think that how to embed the sustainability and how we can make our business sustainable. So I think this is about the sustainability. Now, if we want to embed the sustainability, then 4-5 things, I think nearly 5-6 steps are needed, and that we must be very careful. First thing is, I firmly believe, last 25 year I am in the field of sustainability and embedding sustainability into various corporates. So I get chance to work on the embedding sustainability at Pentair. Then I moved to Shell at Netherlands. Then I was also 5-6 years with Unilever, where we used to embed sustainability into Unilever. And now from last 5 years, I am with UPL. And at UPL also, I am leading the agenda of embedding sustainability into UPL. So what my experience in 24-25 year is, if you want to embed sustainability, then our approach should be from top to bottom. Sustainability cannot be embedded from bottom to top approach. So first, our top management should be very clear, and the sustainability embedding process should start from top to bottom. That is the one things which I get and I learn in the industry. Second thing is, once the top management decided to embed the sustainability into business or in manufacturing plant, then 5-6 steps we need to follow. First step is that we should be very clear with our purpose. And sustainability cannot be embedded if your purpose is not clear. So purpose and vision must be clear, that what we want out of sustainability in our industry. Then the second step is set the goal and targets. So setting goal and a specific target is very important, and that we must set. If any industry, if they don't know the purpose of embedding the sustainability, if they don't have a goal and target for the sustainability, then I don't think they can go in a right direction. And so setting up goal and target is the second step which we should follow. Then the third stage is allocation of resources. The goal and target which we have set, we should try to allocate the proper resources. and then implement the project to achieve those goal and target. And then there should be a review mechanism. Review must happen always, and we should review that where we are going. And then last is the reporting. So through sustainability report, we should must report that what we are doing, where we are going, and where we are against our target and goals. So I think these all are the 5-6 steps which is very important and we should must follow while embedding the sustainability. Now let me just share the presentation, and 1 minute. I'm sharing my presentation. So can anyone say, is it coming on the screen, presentation? The concept of...
Yes, sir, coming.
Yes, sir, visible.
Yes, sir, yes.
Fine. So good. I think now I am going into the presentation, and first let me explain about the UPL. So I belong from UPL, and I am heading sustainability, environment, and green sale at UPL. So I shall take 1 minute to explain about the UPL for those people who are not from the UPL, who are from the other industry. So one thing is peculiar about the UPL is we are world leader in organics, biological, natural products for the farmers. So I think very few people know that today UPL is #1 in biologicals, in biosolutions. We are the 5th largest agrochemical company globally. We are also logo holder of Responsible Care and FTSE for Good. Our operation is in, our presence is in more than 130 plus country. And one of the great thing this year happened that UPL included in Dow Jones Sustainability Yearbook. So now we are member of Dow Jones Sustainability Yearbook, that is the DJSI Yearbook. And very few companies of the world are member of DJSI Yearbook. Only those company, 5-6% companies who are top in the sustainability, their ratings are top in the Dow Jones Sustainability Index, they only get included in the yearbook. So from this year onward, we are member of Sustainability Yearbook. Okay, now next presentation is, this is not related to sustainability, but since various attending, most of people are from the chemical industry, so I thought that let's start with this. Vibrant economy requires vibrant chemical industry. And why I started with this, whenever we used to talk on the sustainability, then normally people feel that the chemical industries are highly polluting industry. And those kind of things associated with chemical industry. But you can see here that how chemical industries and the growth of chemical industry is interlinked with the growth of GDP. And you can see that the top 3 major countries like USA, European Union, China, so top 3 higher GDP country, they also in top in the chemical production. And USA, if you see, they produce chemical worth $765 billion. And if you see China produces $1,500 billion. So those economy who are higher in size, they produce maximum chemicals. And if you see India, our production in chemical production is very, very small. And so why here the message is this, that if we want to become a 5 trillion economy and big economy in the world, then we must have to produce more chemical, because chemical production is closely related to industrial and manufacturing activity. 96% of the manufactured good require chemical to produce. So any industry, if you see, chemicals are used. So normally, one estimate is saying that if we are generating $1 chemical, then it produces further $4.2 elsewhere in the economy. So if somebody is producing $1 chemical, then maybe elsewhere $4.2 business and economy is getting generated. And so why chemical production is very important. And with this slide, I want to give you flavor that in chemical production, we are very small, and India need to produce more, then only we can become a 5 trillion economy in the world. Now coming to the sustainability, so here I shall explain the sustainability with a case study of UPL. So in UPL, we have tried to embed the sustainability, and last 4-5 years, we have done several work, and I think here you can able to get a flavor that how we have embedded sustainability at UPL, and that may be a guiding things for others also to follow. So first thing you can see on the slide, we have first adopted triple bottom line approach for the sustainability. And triple bottom line approach means we have included environment dimension, social dimension, and governance dimension in our sustainability. And you can see the slide what mean of the environment dimension, social dimension, and governance dimension. Once you have embedded the triple bottom line approach, then you need to implement and adopt various policy and management system. And you can see here that sustainability policy, sustainable procurement policy, human right policy, HSE policy, product stewardship policy, tax policy, and sustainability goal and target, of course, we have to include. So I think this policy and the management system is needed, and that must be embedded into the business, and then only we will able to embed the sustainability into the industry. The third step we have followed is sustainability reporting. So every year we used to report our sustainability performance with sustainability report. And anyone can refer the UPL sustainability report. It is available on our website, and you can go at the UPL website, and there you can click the sustainability section, and you can get various reports. All reports are there. Latest report is also there. And once you will go through the sustainability report, you can find several activity and what performance of UPL is, what we are doing in sustainability. Everything is included in sustainability report. And I think the other industry who have implemented and embedded the sustainability, several industries have the sustainability report, but those industry, those business group don't have sustainability report, then they should also came out as per the GRI guidelines. Then the other things we have done, we have taken the sustainability certification of responsible care and FTSE for good. And these two certifications you will not get unless until your track record and your performance is good in the sustainability. So we should must try to get certification from the responsible care. We should must have a responsible care logo and FTSE for good logo. Today, UPL have responsible care logo and FTSE for good logo, and this is very good because when you will apply for this logo, then you have to adopt several good practices, and auditing will take place. And during auditing, also we learn a lot and we improve a lot. So I suggest that we should must go for the responsible care certification, and also we should go for the FTSE for good certification. And last thing is the sustainability rating. And today several agencies are there to rate sustainability, and that is broadly called ESG rating. But worldwide, if you see, the first and I think the most credible agency is DJSI, Dow Jones Sustainability Index from Europe and US. FTSE Russell, it is from London Stock Exchange, and Sustainalytics is rating agency from the Netherlands. So Sustainalytics is also one of the premier ESG rating agency from the Netherlands, Amsterdam. So at UPL, we have taken the rating from all these three agencies, DJSI, FTSE, and Sustainalytics. And what we have found today, if you see UPL, then among agrochemical companies, we have rated #1. So with this presentation, I want to just tell you that how you can adopt a structured approach towards sustainability. And unless until we adopt the structured approach towards sustainability, it is very difficult to achieve the goal and targets of the sustainability. So we should must first have a reference framework for the sustainability, where we should include triple bottom line. We should also must have a right policy and management system to embed the sustainability. We should also must report the sustainability through sustainability report as per GRI guidelines. And also we should must take the certification of responsible care, FTSE for good. And then we can get the rating from the International Sustainability Rating Agency, and DJSI, FTSE, Sustainalytics. These all are the leading rating agency of the world. And if they rate good, then you can feel that yes, your sustainability approach is good. Now this is the next. This is about the Dow Jones Sustainability Index, Sustainalytics, FTSE, and all these international rating agency has rated UPL #1 among agrochemical companies globally. At UPL, what we have done on the SDGs, I think most of people in this training program, they know what is the SDG. So that is the Sustainable Development Goals. And in 2015, nearly 17 goals were set by United Nations. And by 2030, aim is to meet these 17 goals. At UPL, what we do, we have prioritized the SDG. And for our business, UPL, we have prioritized 5 SDG among the 17 SDG. And those 5 priority SDG for the UPL is zero hunger, good health and well-being. Then you can see affordable and clean energy, then industrial innovation, and 12 last 5th is the responsible production and responsible consumption and production. So these 5 SDG we have prioritized for our UPL, and now every year through sustainability report we used to report that what actually we are doing in these 5 area of SDG. Now, as I told you that for sustainability, your vision must be clear and your goal and target must be clear. Here you can see the UPL sustainability vision and UPL goals and target. So if you see sustainability vision, then our vision is working with farmers to help them feed the world sustainably. And our goal for 2025 is first, reduce environmental footprint. Second is enhance world food security. Third is enhance sustainable sourcing. And fourth is strengthen community well-being. So these all are the goals and target of UPL. I will go quickly. Next one. This year, we have also joined United Nations Global Compact to support sustainable development goals. So any industry or any business, if he want to join the United Nations Global Compact, then they must have to follow the 10 principle of UNGC. And you can see the 10 principle of United Nations Global Compact on this presentation. And UPL has confirmed that we will adhere with these 10 principle of United Nations Global Compact. And every year with sustainability report, we used to report against each principle, that what we have done and how we have adhered against all these 10 principles. So we have confirmed that we have accepted this principle, and we are following up these 10 principles of United Nations Global Compact. Now this is the slide which tells you about the sustainability drives profitable growth. And two case study I have shared in this. One case study is from Unilever, where I used to work between 2011 and 16. And the second case study is from UPL, where right now I am working. And there also I have tried to capture between 2016 and 20. So you can see that this 4-5 year duration for both company I have captured, and you can see that when Unilever implemented sustainability, then what kind of reduction they have achieved in environment footprint. Environment footprint reduction means CO2 reduction in their manufacturing plant, water reduction in manufacturing plant, and waste reduction in manufacturing plant. And you can also see the value. So nearly between 2011 to 16, when we implemented and embedded sustainability at Unilever, then personally I found that CO2 emission we able to reduce a specific emission 45%, water reduction we achieved 50%, and waste reduction 47.5%. And if you translate into the worth, then it is nearly $100 million saving achieved through the saving of energy, water, and the waste reduction. Similarly, if you see the UPL, at UPL also from 2016 to 20, our target was to reduce 30% environment footprint. Means we have taken target by 2020, we will reduce carbon emission 30%, water reduction 30%, and waste reduction 30%. But actually you can see on this slide that CO2 reduction actually we have achieved between 2016 to 20, 26%, and a specific water reduction happened 21% from the baseline 2015, and waste reduction we able to achieve 45% from baseline 2015. And if you translate in the worth, then nearly $45 million saving we have achieved at UPL. From 2016 to 2020. So I think these two examples is example which explain or which prove that how sustainability drives profitability, and it's clearly proof that sustainability is for the profitability of business. Now, next is a sustainability drive innovation. So here also our experience at UPL is this, that when we embedded sustainability, then we came out with various innovation, and last 4-5 years, if you see, then several technology we came across and we have implemented and we found very useful. So first technology, a scale ban. So a scale ban is a technology which is used in cooling tower. So in cooling tower condenser, you can, or heat exchanger, you can implement this. And beauty of a scale ban is this, that you can utilize the treated wastewater in your cooling tower, and you can circulate the wastewater up to normally a scale ban used to claim 250,000 ppm TDS, but at UPL we have circulated up to 1 lakh ppm very successfully, and circulating TDS up to 1 lakh ppm or 1,50,000 ppm TDS, we don't found any issue. And we able to save a lot of water through the scale ban technology. And this technology is very simple, and you can utilize your treated wastewater in the circulation of cooling tower. And when you implement the scale ban, then it prevents the scaling of heat exchanger and condenser. So one technology we found which is very good for the water saving. Second technology we implemented volute. So volute is very good for the sludge dewatering. In every industry in ETP, primary and secondary sludge comes, and normally people use filter press or decanter, centrifuge. But this volute is very useful because it consumes very less power, and it is not a batch type, it is a continuous. So even a small capacity volute can run 24 hours, and you can get the desired result, and the power consumption is very less in the volute as compared to the other dewatering technology. So this one technology which we found very good for the sludge dewatering. DIF-MBBR is a popular one, and the same thing we have implemented at UPL also, and we found that it is energy efficient technology and also less space required with this technology, and the purification efficiency increases in the ETP. The last technology you can see in this slide is FO technology, forward osmosis technology. And this first time I think we have implemented at UPL in India. And if you see in agrochemical company, then we are first time we have implemented in the world. And forward osmosis is a technology which can be used for those effluent who have high TDS and high COD. And for high COD, high TDS, this technology is workable, and for those kind of effluent, it is a techno-economic option. And it's practically, we found it's good, and this also provide a better result to us. So I think I have just given a flavor of these four technology which we have implemented in last 2-3 years, and we have gone through a long process. At UPL we have a grain cell, and our process of adaptation of technology is not very easy. We first try to do the piloting at green cell, Then once we found very good during the piloting, then we go for the implementation. And while piloting and implementation, we do number of trial, and we have in-house laboratory, we have in-house our engineers, scientists, chemists, technocrats at Green Cell. So they used to test, they used to pilot, they used to develop this technology. And once we became comfortable and we found that it is good for our operation, then only we implement. So if we are saying that these four technology we have implemented at UPL, it means we have done number of testing and number of experiment and piloting with this experiment, with these technologies. And once we are satisfied, so why we have implemented these technologies at UPL. So this is my request from the participants who are from the other industry. They can also try in their industry, and if they are interested to know much more about the supplier, about the technology, about the advantage and know-how of technology, then they can be in touch with us. They can contact me also. They can contact our Green Sale also, and we are happy to help, and we are happy to provide the support related to implementation of these technologies. Now this is about my recent book, one book that is called Wastewater Treatment Technologies Design Considerations. So this book I have written, and Ville is a very renowned publisher of US and UK. I think it is 200-year-old publisher, very renowned publisher in the world for the technical books. So Ville has published my book in March 2021 recently, and this book is very good, and it's provide a practical approach toward the wastewater treatment. So the book takes a holistic view of the practical problem faced by industry and provides multiple need-based solutions to tackle wastewater treatment and management issues. And you can see the content. The content in this book I have covered. First is the global perspective of wastewater treatment. Then second is wastewater characteristics. Under wastewater characteristics, this is a very good section of this book where I have summarized nearly 30 industrial effluent characteristics. So whenever you want to design a wastewater treatment, the biggest challenge happens that what will be the input characteristics. And in this book, based upon the practical experience, near more than 30 industries, effluent characteristics has been summarized, and you can refer those tables and you can get. And those all characteristics are practical, which I have seen in the industry, and it's not a theoretical. So it will give a approximate near right characteristics of that industry. Then third chapter is wastewater treatment technologies. So under wastewater treatment technologies, I have covered several technologies because at different effluent, different technologies work. So I have tried to summarize most of technology which are practical and which are techno-economical, very good for the industry. So that has been summarized in this book. Then design consideration. Design consideration is a heart of this book, where all the design methodology and steps to design formula, those things has been covered in the fourth chapter. Fifth chapter, advanced sustainable wastewater treatment technologies. There I have covered some of the latest advanced technologies like a scale ban, forward osmosis, volute, and similar latest technology which are not available in any textbook or books. And fifth chapter is zero liquid discharge. So One chapter completely I have devoted on the zero liquid discharge, and also I have tried to provide my experience with the feasibility of zero liquid discharge. And then the last chapter is wastewater treatment plant operational excellence and troubleshooting. And in this chapter, how to operate the effluent treatment plant and how you can get a better result by a better operation, that things has been included related to operational excellence in the last chapter. So I think this will be very useful, and if you want to refer, it is available. You can go online on the Ville library. You can order from there also, from the Ville directly. You can also order from the Amazon. So in Amazon site also this is available. And a part of that, several e-commerce sites like eBay, Red Shelf, Booktopia, Layman's, Waterstone. So several e-commerce sites it is available, easily available. Anyone interested, they can get it. So this is about my book. Now coming to the topic on the sustainability. So sustainability is a very vast area and several things get included, and several times it's become very difficult that in 1 hour or 1.5 hours we can cover everything. But what I shall do, I shall try to cover some of the aspect of wastewater treatment. Because in chemical industry, what I used to find that today our industrial people, especially the operation people, they are struggling and they are finding problem related to wastewater treatment. And I shall take some time today to explain that what kind of best practices we can adopt in the wastewater treatment. Also, you will see the sustainable scheme, and I shall share with my experience with ZLD. So those things we will cover during this presentation, and then I will conclude. So coming to the best practices in wastewater treatment, what I feel that our approach should be, our maximum approach should go on reducing. So first you try to reduce the water consumption as well as wastewater generation itself in your manufacturing operation. And that should be our first priority. Then second priority should be maximize the recycle and reuse during production. So if we can find the effluent which can given a small treatment and immediately we can recycle and reuse, then I think that will be a best methodology and best approach inside the manufacturing plant. Then the third step, segregation. And I feel that effluent segregation is very important to manage a complex effluent, especially the large manufacturing plant and multi-product manufacturing plant. See, effluent segregation work very well. And fourth is treat. Of course, we have to deploy sustainable wastewater treatment technology where we can treat in a better way. And then last is the disposal, and the incineration we should avoid as much as possible, because when we do the incineration, then a lot of energy get consumed, so a lot of carbon emission happen, and it is very costly also, so it's make unprofitable also our business. So incineration is the last one, and we should always try to eliminate the incineration in the wastewater. So I think a structured approach toward wastewater treatment help us to manage complex industrial effluent, that I want to give a flavor through this presentation. Now coming to this slide, here I want to show you a sustainable wastewater treatment scheme. So this may not hold for every industry good, but in our operation, mainly in the chemical industry, these schemes work very well. And here you can see sustainable wastewater treatment scheme. And let me explain. I will take maybe 2-3 minute time to explain this, because this is very important, and we need to embed and implement this sustainable wastewater treatment scheme for the better wastewater management inside manufacturing plant. And this holds very good for the chemical industry. So first thing with this scheme, I want to tell you that first you adopt the approach of wastewater stream identification, characterization, segregation. So normally we try to segregate our wastewater in three streams: green stream, yellow stream, and red stream. And green stream means those effluent which TDS is below 5,000 ppm and COD is below 10,000 ppm, that we treat as a green stream, because very easily we can treat with a biological treatment plant. So we channelize all the green effluent at one place, and we treat the green effluent with biological treatment, mainly with either activated sludge process or MBBR technology. Then the second stream is a yellow stream. Yellow stream is those stream where TDS is moderately high, between 5,000 to 1 lakh ppm, and COD is also moderately high, 10,000 to 20,000 ppm. So those effluent which TDS is more than 5,000 ppm but less than 1 lakh ppm, and COD is more than 10,000 but less than 20,000, we treat as a yellow stream and collect all those yellow stream at one place, and you may apply membrane technology to treat it. Oxidation technology also work very well for this, and most popular is the forward osmosis can be implemented for the treatment of OH. Also OH radicals are very good technology to treat the OH radical, and advanced chemical oxidation also work to treat the yellow stream. The third stream is red stream, and red stream is those stream where effluent TDS are higher than 1 lakh ppm and COD are higher than 20,000 ppm. And those red stream effluent we can collect at one place, and the appropriate technology is either multi-effect evaporator or catalytic wet air oxidation. So slightly it is a it is a costly treatment method, but for red stream we have to adopt a costly treatment approach. So you can see on this slide that how we have segregated the effluent into green stream, yellow stream, and red stream. Then we have applied appropriate technology. For the green stream, we have applied biological treatment, mainly activated sludge process or MBBR. For yellow stream, we have applied membrane or oxidation treatment, and for red stream, evaporation treatment technology. And then the condensate of the evaporation treatment that can be reused, reutilized. Under forward osmosis, the reject can utilize through the scale ban, and the permit can be directly reused. And through biological treatment, the treated effluent can pass through the scale ban into the cooling tower. So by that way, we can achieve the zero liquid discharge also, and we can have a best treatment scheme and best techno-economic treatment scheme inside the industry. So I think I have summarized this quickly, and don't think that only these 3-4 things are there in the scheme. So if you want to understand more, or if you want to implement, then again this is my request that anyone can contact us, and we are always eager and excited to help the people, even those people who are at Bharuch or Ankleshwar area, those industries who are not from the UPL, But if they feel that they need certain help or certain technical know-how, certain guidance, then don't hesitate. You can approach to me, or our team is there. Our UPL environment team is at Ankleshwar, so they are also there. Ajay Pancholi is there, Pravesh is there, Vinay is there. At our green sale also, several peoples are there. So you can approach them, they will guide, and you can approach to me also. We always feel that in Bharuch and Ankleshwar area, every chemical industry need to do the right treatment. And if you need any kind of help in the effluent treatment or embedding the sustainability or environment protection, so we are always there, and we are always there to help free of cost. So I think this is about the scheme. Now moving to next one. This slide I have prepared mainly our experience with ZLD. And let me tell you, as an environmentalist, I am against the zero liquid discharge. I always found that ZLD is not an environment friendly technique, and we should never ever follow ZLD blindly, especially in the area, in the coastal area. So those industries who are situated in coastal area like Ankleshwar, Bharuch, Panoli, Jagadia, we have already deep sea discharge facility available. So I feel that treat the wastewater to meet the standard discharge norm and then discharge into deep sea. That is a best techno-economic option, and that is best for the environment also, rather than going for the zero liquid discharge. And why I used to say that ZLD is not an environment friendly technique, you can see through this presentation. Some of the data I have correlated here, and this data is not a theoretical data. This data is based upon the practical data which we have at UPL. We have, because we have also ZLD plants. We have operation in our unit 2. We have zero liquid discharge. We have achieved ZLD at Tarapur. We have achieved ZLD at Halol. And now we are in process of implementing ZLD at Unit 1. So, what I feel that when you will see the operating cost, when you see the power consumption, then you will find that the operating cost to meet the ZLD norm is 3 times higher to meet discharge norms. And CO2 emission, carbon emission is 4 times higher in ZLD than ordinary meeting the discharge norms. And since the carbon emission is 4 times higher, CO2 emission is 4 times higher, so why, as an environmentalist, I used to personally oppose ZLD. I used to tell that don't adopt ZLD if it is in the coastal area, and the better and good option is this, that you treat your wastewater and meet the standard discharge norms and then discharge into the deep sea. And that may be a very good and techno-economic option, environment-friendly option, than making your plant zero liquid discharge. So I think you can see here, I have given one example of one MLD effluent treatment plant, and where I have assumed that TDS, inlet TDS, will be around 3000 to 4000 ppm, and COD will be around 4000 to 5000 ppm. That is my assumption, and that is the basis of this data. And that effluent first pass through the biological treatment, and then we have implemented reverse osmosis, and reverse osmosis reject is going through the multi-effect evaporator. And you can see the ETP cost for the biological treatment, it is coming around 500 rupees per cubic meter. UF RO cost coming around 136 rupees per cubic meter, and the AME cost is coming around 3000 rupees per cubic meter. And when you will find overall cost of ZLD, combining all ATP, RO and AME cost, then overall it is coming nearly 1500 rupees per cubic meter treatment cost. So if you want to meet the ZLD, then I think at least 1500 rupees per cubic meter comes as a operation cost. And power cost, if you see, then ETP consume, normal biological ETP consume nearly 3 kilowatt hour per cubic meter, UFRO consume 5 kilowatt hour per cubic meter, and ME consume 30 kilowatt hour per cubic meter. And if you see overall power consumption, then it is coming around 13 kilowatt hour per cubic meter. So I think clearly this data is saying that the operation cost to meet ZLD norm is 3 times higher to meet discharge norm, and CO2 emission is 4 times higher in ZLD to ordinary meeting the discharge norm. And these all, based upon this data, I always use that in a coastal area, ZLD is not an environment friendly technology. And I think at ministry level, Ministry of Environment Forest, already one committee has been constituted by Ministry of Environment Forest to look into the ZLD and suggest the right approach toward ZLD, and also suggest whether we should make mandatory or not mandatory ZLD. So that committee is working, and very soon I think the recommendation will come, and then let us see what recommendation is coming. But as on date, discussion is going on and committee is evaluating ZLD norms. Now, in the favor of ZLD, what people used to tell that since water scarcity is there, then we need to implement ZLD, because when we will implement ZLD, then we will use all the water and there will be less water requirement inside industry. That always comes one of a favorable point in favor of ZLD. But what I have summarized here, that you can see that industry have all the 4 options to use as a water. One is the supply water, so that I have not included into it. Supply water is another one. But a part of supply water, we can have a ZLD water, we can have a desalinated water, we can have a sewage water which can be treated and used inside industry, and the rainwater. And you can see the cost. So that ZLD water is costing somewhere between 1000 rupees to 15,000 rupees per cubic meter. Desalinated water cost somewhere between 50 to 80 rupees per cubic meter. And if you take sewage water, treat and use, then it will cost nearly 30 to 35 rupees per cubic meter. And if we are using rainwater, then rainwater is the cheapest source of water and the good quality water that is less than 10 rupees per cubic meter. So these treatment costs clearly showing that in coastal area, I think we may use desalinated water, treated sewage water, rainwater, which will be a better choice than ZLD water. So instead of ZLD water, if we switch over to these water, then it will be economical and the better choice for the water inside the industry. With rainwater, the only problem is that it's available only seasonal and it cannot be made available throughout year. So that is a drawback. Otherwise, rainwater, if we can collect, treat and start using inside operation, then that will be a cheap and best option. At UPL, we have implemented almost all our operating plants. And what we are doing, we are not harvesting inside the ground. We are collecting the rainwater, then we are storing, and then we used to treat a very small treatment we used to provide, and then we use inside our operation. And that's come out very good and very good, better option for the water, and one of the cheapest option for the water use. So, but the only drawback is rainwater available only seasonal, not available throughout the year. So I think we will park maybe some times for the question answer also. So what I want to summarize in sustainability, that sustainability is for the profitability, sustainability is for 100% compliances, sustainability is for a smarter innovation, and sustainability is for environmental protection. So I think the summary is this, that sustainability is for profit, sustainability is for people, sustainability is for planet. So this is the conclusion. Now I think this slide will take much more time, but quickly I will go through it. Normally, whenever I used to meet with industry people, then I used to show this presentation. So quickly I will go. How much time we have?
Sir, we have around 25 minutes.
20 minutes. Okay, so quickly I will go through this. So what I want to explain through this slide, that if you see the chemical manufacturing, then I have compared with India, and in global manufacturing, India is lower. We manufacture lower chemical than rest of the other developed world, and you can see the data through this table, and you can see that how a small amount of chemical we are exporting as compared to other developed nations. Now, as far as CO2 emission is concerned, you can see per capita CO2 emission of India is very, very small as compared to the other developed nation of the world. Then third thing, you can see ecological footprint. Ecological footprint also, India ecological footprint is very small as compared to the other developed nation of the world. And here ecological footprint means if all the world people start adopting the living style of India, then you need only 70% of our earth to sustain entire world population. But if all the world population start adopting the lifestyle of USA, then you need 4.8 earth. Nearly 5 earth is needed to sustain this world population. So our ecological footprint is very small. Then you see the effluent discharge standard. India effluent discharge standards are stringent than rest of the developed countries of the world. So what I want to show here, that our manufacturing is less, our carbon emission is less as compared to other developed nations, our ecological footprint is less, our effluent standard to discharge is very stringent, so we are not polluting the sea or the water bodies. So the summary is that India is not part of global environment problem, but India want to be part of global solutions. So some of the myth comes that we used to produce large chemical, we used to pollute most. That is a myth and that is not a fact. So I thought that let's share this presentation among all of you, because all of you are from the chemical industry. So you should, I think most of people may be knowing this fact, but just I have shared this fact. Now I shall present one presentation. This is recently MFG Pro Media have made, and here I have explained about the sustainability and how sustainability stands for the profitability of business, how sustainability stands for innovation, and how we have embedded. So it's 10-minute video. Just go through it, and then we will come for the question answer. So just watch this video, 10-minute video. Is it coming?
Yes.
Yes, sir.
We believe that sustainability provide best opportunity to business to drive smarter innovation and profitable growth. Smarter innovation means sustainability provide opportunity to embed green sustainable technology where you can save a lot of energy, a lot of water, and a lot of expenditure on the waste. At UPL, to embed sustainability, we have created Green Cell, and at Green Cell, there are a number of engineers, biologists, technocrats, chemists. Day and night they are working to develop green sustainable technology, which can be implemented and embedded inside UPL to bring down the UPL environment footprint of operation. And we have developed number of technologies. Some of the technologies are scale band technology. So there we have reduced a lot of water in the cooling tower. We have developed, piloted, and embedded volute, which helpful in wastewater management. We have piloted and developed forward osmosis. I think forward osmosis first time in the UPL we have embedded among the world in agrochemical company, and it is a very good technology to treat the wastewater. We have developed OH radical, which can treat the high TDS effluent. So I think by this way, we feel that sustainability provide opportunity for a smarter innovation. Sustainability also provide opportunity for the profitable business, profitable growth. And I think in last 10, 11 years, what I found that between 2011 to 16, when I was in charge of sustainability of Unilever, and when we implemented sustainability at Unilever, then we found that we able to save nearly 100 million US dollar worth water bill, energy bill, and waste. Similarly, between 2016 to 2020, I am with UPL and I am heading globally sustainability and environment at UPL. And here also we embedded sustainability and brought down the environment footprint of UPL 30%. There what we found, when we calculated, then we able to save in last 4 years nearly 45 million US dollar worth water bill, energy bill, and the waste disposal cost. So it's clearly saying that sustainability is for the profitability of business. I think that especially when in 2015, United Nations brought SDG, Sustainable Development Goal, and Paris Agreement on climate change, then sustainability became more relevant because we believe that the cost of inaction on the SDG and Paris Agreement is higher than the cost of action. At UPL, we have embedded sustainability by embedding a triple bottom line approach in sustainability strategy. Triple bottom line approach means we have embedded environmental dimension, we have embedded social dimension, and we have embedded governance dimension in our sustainability strategy. So if I say environmental dimension means we have adopted a better water management system, we have adopted better environment management system, and we have adopted better eco-efficient operation. Social dimension means we have implemented very good practices on the HR. We have brought a very good policy and processes related to safety, and we have done a lot of work how to achieve the SDGs. And governance, under governance, we have brought various policy related to the good governance and also the customer care, quality policy, tax strategy. So those kind of things embedded under governance. So we have implemented triple bottom line approach in our sustainability strategy. I think to embed sustainability at UPL, we have done 5 things. First things, we adopted a triple bottom line approach. Second thing, what we did, we brought several good policy and management system in place to embed the sustainability. Like climate policy we brought, environment management policy we brought, tax policy we brought, human right policy we brought. So those kind of a good policy related to sustainability we brought and implemented. Third things we did is a sustainability reporting, and regularly as per GRI guidelines, we used to publish the sustainability report of UPL, and it is third party authenticated, it is third party assured report, and every year we used to report the sustainability report where everything we place what we are doing. Fourth things, we adopted the practice of taking very good international certifications, like we have taken the responsible care certification, and also we have taken FTAC for good certification, and that provides us guideline and a standard to implement the sustainability at UPL. And the last part we did, we participated in international sustainability rating agency like DJSI, FTAC, Sustainalytics, and we found that in last 3-4 years, these all international sustainability rating agency has given very good and higher rating to UP. Recently, one of the premium ESG rating agencies, Sustainalytics from the Netherlands, they have rated UPL #1 in the sustainability among the agrochemical company globally. If you see Dow Jones Sustainability Index, they have also rated us above industry average. FTAC has also well rated us. So we have adopted the practice where we participate in this rating and we got a very good result. So I think this way we are implementing sustainability and embedding sustainability at UPL, and by this way we are able to reduce our environment footprint. Nearly 30% of our operation environment footprint we able to reduce by implementing the sustainability, and which provide us not only social benefit where we able to reduce our environment footprint and pollution, but also it helps a lot to achieve the beyond compliances, and it also helps in monetary benefit where nearly 45 million US dollars we able to save on the saving of water, energy and waste. Hello.
Yes.
So I think with that we will conclude this now. Question answer, if any, then we can have a question answer session and then we will conclude.
I would like to request to all the participants, if they have any query, they can ask one by one. Hello, am I audible?
This video was coming audible or it was not audible? The last video which I have shown.
It was audible.
Okay.
So, participants, if you have any query, please you can ask one by one.
Hello, sir. Sir, I have one query.
Yes, but the voice is breaking.
सर जो स्केल बेन टेक्नोलॉजी है
Jeevan ji, your voice is not clear.
सर अभी आ रहा है वॉइस हेलो हेलो
No, voice is
No,
breaking.
yeah.
हेलो हेलो सर वॉइस आ रहा है अभी
Do we have
Sir,
option
आपकी
to
voice
write the
clear नहीं आ रही.
question?
ओके
You can write your query in chat box also.
ओके ओके
Okay, we have sir one query in chat box from Pratik ji, Pratik Patil. Uh, he's interested to know about the how the target was set. Uh, is Pratik sir is available?
So actually, while setting up sustainability target, we have to two things are there. One is the science-based target. So if you that is a best way to set the science-based target, and for that the company have to work along with CDP and United Nations Global Compact. They used to ask all the manufacturing and emission details, and then they try to see that how by 2035 you can achieve certain goals, and how 2050 you can have a carbon neutral, how we can achieve the goal by 2030 Paris Agreement. So I think science based target is one of the best way to set the target. But if you not able to set the science based target, then the company can practically see that how much emission he can able to reduce by in coming 5 year or 10 year. So then they can set the target.
Okay, sir. So sir, next query is from Girish Rohit ji. He wants to know about the reference of volute and scale band technology to know the process involved and supply.
Reference of
Reference of volute and scale band technology. He wants to know about the process of volute and scale band technology.
okay. So I think you can write separately, then we can provide the process and write up about the scale pan and the whole.
Girish Rohit ji is requested to write a mail to us or sir to know the reference about the this technology, and he wants to know about the supplier also, available supplier for volute technology.
Right.
Sir, another query is from Priya Patel ji. He wants to know about that they have installed the scale band technology since last 1 year in pharmaceutical company, but is not successful. So please kindly guide on any other technology related to the pharmaceutical technology, pharmaceutical company.
So his question is related to a scale ban, that his experience is not good.
Yeah.
Okay. So I think we need to understand that what kind of effluent they have passed through the scale ban, because there are certain limitations and certain parameters they need to treat, and then only they can pass through the scale ban. So unless until we know all the things, all the detail that what kind of effluent they are passing, how they are using a scale ban, even in a scale ban we have to be very careful that the where you are locating this equipment, because it should be very near to the heat exchanger and condenser. If there will be more distance, then also this technology doesn't work. So I think once we will go through all those things, then only we able to comment that why it's not working, what they need to do.
Priyaji, you can share the characterization of your effluent so that we can share with the sir, and he will definitely will help you about the scale band. Or sir, if you want that any other technology is available for the pharmaceutical company in place of scale band.
I think the other technologies are you can have a conventional effluent treatment plant, also some advanced effluent treatment plant. Then you can treat at tertiary stage. Forward osmosis, one technology is there. If TDS is higher, if TDS is lower, then the RO also work very well at the tertiary stage. So several technologies are there. It all depend upon your effluent characteristics. And in pharma industry, what the challenge is that if your dissolved salts TDS is less than 5,000 ppm, then you can have a biological treatment. But if your TDS is higher than 5,000 ppm, then biological system doesn't work well. And if more than 10,000 ppm, then it doesn't work at all. So then you have to think about the advanced oxidation process or OH radical technology. So it's depend upon the characteristics of effluent, and then the appropriate technology comes in picture. So actually the effluent treatment is a very complex in nature, and several times we understand that any technology or any scheme will be workable. It is not like that. Even in pharma also, product to product characteristics go on vary. So we should be very careful that what is characteristics of effluent, and then only we can apply the appropriate technology.
Okay. We have another query from Jeevan Chaudhary ji. He is telling that scale band is not recommended by Pollution Control Board.
So pollution control board guidelines is this, that if COD is more, means maybe more than 2000, 4000 ppm, then they don't allow to circulate, because they feel that some kind of a smell will come inside the plant when you are circulating the organic impurities. But as I told you in beginning, that don't use raw effluent in a scale ban. First, you treat the effluent, bring down COD less than 250 ppm, and then you use inside the scale ban for the recirculation into cooling tower. So several people feel that they can use the raw effluent, then this problem comes. And also the pollution control board problem only comes when some smell comes because of organic impurities. If a smell is not coming, then they don't object.
Sir, next query is from Manoj Kumar Tiwari ji. He is telling that volute press moisture content high compare than filter press. It will increase disposal cost also.
So actually, it's depend upon how you are operating, because in volute one, a skilled or one care should be taken that they used to add a certain polyelectrolyte such that a good flock can be formed, and then you get a better dewatering. And there are some people who don't use right polyelectrolyte, right chemical to form the flock. Then yes, then they end with the more moisture in outlet, and then it's become uneconomical than the other. But I think those problems are associated with the other dewatering advice also. Because in other dewatering advice also we have to make the flock and then only it work well.
Yes. Sir, another query from Sagar Gajjar. He wants to know that R&D cell and sustainability cell is similar or different?
Can you repeat again?
One query from Sagar Gajjar ji. He wants to know that R&D cell and sustainability cell is similar or different?
So R&D sale and sustainability sale. This is question.
Cell, yes.
I think
Yeah.
it's entirely different. R&D sale is for research and development, and sustainability sale is for the embedding sustainability, reporting sustainability. So I don't think any similarity is there between R&D and sustainability. Entirely different set of people require, and both are different than each other.
One more query from Harsh Kumar ji. He wants to know about the best way to remove phosphorus and nitrogen from wastewater.
So actually, this is the biggest problem, and in some of effluent, not with all the effluent, but in some of the peculiar effluent, the phosphorus removal and nitrogen, this happens to be problematic. So normally, we try to design the system where nitrification, denitrification, and then again nitrification happens, and that should be very carefully get designed in activated sludge process. So nitrification and denitrification is very important if you want to remove, or if you have problem of nitrogen.
So next query is from Akruti Patel. He wants to know that please throw some light on how OH radical technology works for treating moderate levels of TDS. He wants to know about the OH radical technology.
Okay, so actually OH radical technology we used to adopt when the effluent not possible to get treated with biological treatment. So mostly in chemical industry, we get the stream where the TDS are very high, like 50,000 ppm, 70,000 ppm. If TDS comes in the effluent, then it's become difficult to treat with the biological treatment. And those effluent can be treated with OH radical. In OH radical, we used to adopt a practice where we generate the OH radical. So there are several companies who provide the OH radical generator, and that OH radical get generated, and with fine bubble diffusers, we diffused into the effluent, and that OH radicals are powerful oxidizer, and they come in the contact with the effluent and oxidizes the organic impurities. But one thing is there, when you adopt OH radical, then the technique or treatment can be possible for the higher TDS effluent, but it doesn't remove the TDS. It only reduces the COD, it only reduces the BOD, also it disinfect the effluent, but the TDS remain as it is. TDS never ever get reduced by the OH radical. So if your aim is just to reduce the COD, BOD, and the biological impurities, then OH radical is fine. But if your aim is to reduce TDS also, then don't use OH radical, because OH radical don't reduce TDS.
Okay, sir. Bhaviksha ji wants to know how to determine whether to use anionic polyelectrolyte or cationic polyelectrolyte.
So this always happens with the jar test. So whenever the polyelectrolyte suppliers comes, they do the jar test, and this is the things which never ever can be recommended blindly. Always they conduct the jar test on the site. They see that which polyelectrolyte is making more flock, and then they recommend. So between cationic anionic, several times it happened that today cationic polyelectrolyte is working very well on your effluent, and maybe after 2 3 months the characteristics of effluent get changed, and then the other kind of polyelectrolyte needed. So always believe on the jar test, get jar test done, and it is very simple. They used to take the effluent and they first apply the cationic polyelectrolyte, and then see that how the result is coming, and then they apply anionic, and then they see whichever the result comes better in terms of flock formation, they used to recommend it.
Okay, sir. Diviji wants to know that volute technology alone cannot dewater sludge proper. A pedal dryer after volute can be placed.
Yes, pedal dryer can be placed after the volute. If you want that the moisture content should further reduce from 70% to, let us say, 30% or 20%, then you need a pedal dryer or any other dryer, because volute can reduce only moisture content up to 70%. If you want to go lower than 70%, then you have to apply some dryer, and paddle dryer is one of the dryer which can be implemented.
Uh, there's another query from Harsh Kumarji. Is it possible to remove TDS through SDVR or MBBR?
No, no. MBBR is a biological treatment process, nothing to do with TDS. In fact, we should be very careful. If TDS is more than 5,000 ppm, then performance of MBBR get affected. And if your TDS is more than 10,000 ppm, then very less performance comes out of MBBR technology. So TDS affect the performance of MBBR technology, but TDS never ever get reduced by the MBBR technology.
We have another query. Sir, as per effluent treatment you guided, if COD is 10,000 in biological plant, then what should be BOD must, and what will outlet COD expect after treatment?
Can you repeat again this question?
Question is that as per effluent treatment you guided, if COD is 10,000 in biological plant, then what should be BOD must, and what will outlet COD expect after treatment?
So actually, BOD and COD, there doesn't happens to be much more correlation, but yes, practically we have seen that nearly if your COD is 10,000 ppm, then BOD we get in range of 3,000 to 5,000 ppm. So sometimes 2,000 ppm also. So it's depend upon nature of effluent. But another important thing is that BOD will be always lesser than COD. Now, when 10,000 COD is coming at inlet, and at the outlet of biological system, what will be? So answer is that we try to keep less than 250 ppm, because that is the norms, standard norm. So normally we use to bring down COD at the outlet less than 250 ppm. So as per the norms that we want to achieve.
The last query is from Bhavik Shah. Can volute remove TSS content in high COD effluent?
Yes, TSS only get removed by the volute.
Yes, sir. So, whatever queries we have received in check box, these all are discussed. So, I again request to participants, if you have any query, please ask so that we can end up the session.
Right. So thank you to all the
I
audience.
think there is no query. Thank you, sir, on behalf of SRICT and Department of Environmental Science and Technology. I would like to extend my sincere thanks for delivering such informative session on the concept of sustainability for industry. And I would also thanks to accept our invitation for this short-term training program and for sharing your valuable time with us. Thank you very much, sir.
Thank you.
So thank you, sir.
Thank you, Dr. Chaube. It was a nice session, Dr. Snehalia. It was a nice session, sir. Thank you so much.
Thank you.
Thank you.
Thank you.
Okay, thank you, sir.
Thank
Thank you, sir.
you.